you understand about this term, electronegativity? Anyone having any idea? Jasmine, do you have any idea what is electronegativity based on your understanding?
There are electrons which have negative charge.
Okay, electrons that has negative charge. Okay, fine. Okay, Audrey, what do you understand about electronegativity? By just looking at the term.
Yeah, the negative charge of the electrons.
Okay, negative charge of the electrons. Okay. Josh, what do you understand? Electronegativity.
Like magnets.
Okay. Can you actually explain more? It's very interesting.
Positive, negative.
Actually,
I don't know.
when you use the term magnet, it's very interesting concept. It's like kind of okay. It's if later when we want to explain using the magnet concept also is quite applicable actually. Okay, but Frederick, let's actually see what do you understand about the term electronegativity?
The electrical charge of a atom.
Okay, electrical charge of the atom, that's actually negative charge. Okay, so let me actually just introduce to you. Okay, the electronegativity is actually towards the end. Okay, you just say it's actually an ability. Ability of what? Okay, ability of a particular atom. Okay, ability of particular atom to attract. Okay, to attract what? Okay, you can see electronegativity. So what do you think? To attract what, Jasmine? What do you think? Based on Josh's definition of magnet, I told you it's almost similar to that. To attract what?
Other atoms.
Other atoms, not really. Okay, because there's electronegativity, definitely got to do with electron. Okay, so Arwen, what do you think? Okay, ability of a particular atom to attract what?
Electron from other
Atom. Okay, electron from another atom. Very good. Okay, very good. But this one, okay, what kind of electron that they are actually attracting? Do remember, okay, we have, when we say electron, okay, from other atom, is it actually, if you have Cl and Cl, is it the ability of the Cl to attract the electron from some other Cl or some other molecules? Or is it actually trying to attract within the molecule? That's very important. Okay, you need to actually take note of this. So according to this definition, okay, the definition is to attract the bonded pair of electron. Okay, to attract bonded or covalently bonded electrons. Covalently bonded electron from another atom. Okay, to make it simple, if I have Cl and Cl, if I use the term electronegativity for this particular atom of Cl, it means that, okay, if I just put it in terms of electrons, okay, it means that the ability of this Cl, okay, to attract this bonded pair of electrons towards itself, that is called electronegativity. So do remember, this term electronegativity is used for covalent compounds or ionic compounds. Ryan?
Yes, sir.
Electronegativity is a term that we use for covalent compounds or ionic compounds. Which one do you think? Based on the
Ionic?
definition. No.
Oh, covalent.
Yes. Based on the definition, it means we are talking about covalent compounds. Okay, we are talking about covalent compounds. So we can actually have a lot of covalent bonded, like for example, Cl, 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 and Cl. This is also a molecule which we call tetrachloromethane. Okay, tetrachloromethane is basically comes from methane. Methane is CH4. So all the hydrogen, the 4 hydrogen has been replaced by Cl. Okay, so that's why tetra means 4. Okay, chloro means 4 Cl. Okay, and then methane. Yeah, Michelle V. Wait. Yes, can. Now, so that is actually tetrachloromethane. Now, when you look at this tetrachloromethane, okay, when we actually try to apply the principle of electronegativity, it means that you have electrons somewhere here, electrons somewhere here. So the electrons can be either going towards the Cl or it can go to towards the carbon. Okay, they can either go to Cl, it can go to carbon. So I need to know where it's actually moving. Another example is going to be HCl. Okay, we know that it's a very special type of molecule. Okay, but you see here, this is the covalently bonded electron. I want to know whether the electrons over here, they are going to be moving towards Cl, or whether they will be moving close towards H over there. So it means that it's not exactly in the middle. It means, to be exact, the electrons, are they perfectly in the middle? Not really. Okay, it depends on the ability of this atom or this atom to pull them closer to each other. So how do we actually know which one will have a better ability, okay, to pull the electrons? So in order to do that, I think in order to be able to pull the electrons, I think your proton must be very strong. It means you must have a lot of number of proton. It means your nuclear charge must be higher. Okay, nuclear charge must be higher in order to be able to pull the electrons. So here, if you have your periodic table, okay, I think one of the common things that we need to know about the periodic table is, as you go across the periodic table, you know that the atomic number increases, your proton number increases. And let's say from the same period, okay, okay, we know that we are talking about the same number of shells, okay, so the shells remain constant. Okay, if the shells remain constant, it means your shielding effect is also constant. Okay, please actually find out what is the meaning of shielding effect. Last time we already learned. Okay, your shielding effect is constant. And I know that my proton number, okay, is actually increasing. It means my nuclear charge is increasing. It means that, okay, the electrons, they are going to be pulled closer, okay, by the nucleus, okay. And as they go across the periodic table, generally we will see that the atom tend to actually have a decrease in the radius. It means it becomes smaller and smaller. Why they become smaller and smaller? I already wrote the reason. The shell remains constant, the shielding effect remains constant, the number of proton increases, the nuclear charge is more. It means they will actually pull the electrons closer to itself. So we can say the atomic radius is going to be decreasing. The moment you see the atomic radius is decreasing, that's already an indication that they are strong electronegative atom. Okay, they are strong electronegative atom. Now, if I have H and Cl, if I want to find out which one is more electronegative, okay, we know that hydrogen is 1, yeah, 17, okay, chlorine is 17. And if you look at your periodic table, it's under group 17, which is somewhere here, okay. So you can see that, okay, chlorine, okay, definitely will have a stronger, it means the proton, the nuclear charge of the chlorine atom, okay, is really strong, where they can actually pull the electrons from the hydrogen towards itself. So if I have HCl, this electron is no longer going to be in the middle. The chlorine, okay, having the more proton number, okay, they will actually pull it much more closer towards itself, okay, and the other electrons, they are going to be like this. It means, what does it tell me? Okay, it just tells me that, okay, they are kind of not so symmetrical. Okay, when they are not so symmetrical, what happens is, just imagine I put it as a molecule. If I put them as a molecule, it means that there is more electrons. Where? Is it actually more electrons towards hydrogen, or is it more electrons towards chlorine? Maxwell?
Chlorine, sir.
Yes. So that actually makes it to become a partially negative. Okay, that's delta negative means partially negative, because more electrons towards chlorine. And this one is going to be partially positive, partially, yeah, partially. So that actually creates, okay, that creates a polarity. What is polarity? Polarity means there is going to be positive charge and negative charge within the molecule. So that actually creates a polarity. So to say that, okay, is this molecule HCl, is it polar or non-polar? Okay, if you have polarity, it means they are polar. Okay, if they have polarity, they are polar. Now, I give you another example. What happens if I have Cl and Cl? Ryan, do you think it's going to be polar or non-polar?
Non-polar.
It's going to be non-polar because, okay, the chlorine and another chlorine, it means they are going to have the same electronegativity. It's the same atom, same electronegativity. If they pull the electron towards themselves here, the same strength, you are going to pull it over here. So they are going to be in the middle. If they are in the middle, okay, the electrons are equally shared. If they are equally shared, there is no delta negative, or there's no partial negative, and there's no partial positive. So therefore, this is going to be non-polar. I'll give you another example. If I have CH, another H over here, and then I have Cl, and I have another Cl over here. Now, is this polar or not? Okay, let's actually see whether they are polar or not. You have carbon, okay, you have carbon, you have chlorine, and you have hydrogen. Okay, now when I want to see the electrons, whether they are going to be pulled where and so on, you see the carbon and chlorine. Okay, let's say I want to see over here carbon and chlorine. Okay, if you look at the periodic table, carbon is here, chlorine is all over towards the right hand side of the periodic table. It means that chlorine is more electronegative than carbon. It means the electron, they will go towards chlorine. The same thing will apply here. The electrons will go towards chlorine. Now, for carbon and hydrogen, okay, this one you memorize. Okay, carbon and hydrogen, they have found out that the electronegativity, even though they are different atoms, they found out that the electronegativity is almost the same. So no need to worry about that. Okay, imagine it's still in the middle. Carbon and hydrogen, yeah, it's still in the middle. Electronegativity is almost the same. Now, when you see here, okay, if I actually represent this, okay, we know that they stay in the middle, they stay in the middle, but imagine you have a tripod stand, and then two parts, the electron, they gather around here. The electron, they gather around here. Here, they still stay in the middle. But when you look at it overall, what can you actually see? This part, this entire part, it will look like you have a lot of electron. It means you are going to have a delta negative here, and you will have a delta positive over there. So there is polarity. So we call this polar. Is that clear, guys? Now I'll give you another one more example.
Sir,
Yeah.
sir, why is the electronegativity of hydrogen approximately the
is?
same as the one from carbon?
Okay, it's like this. The chemists, okay, we actually found out, like I told you, the definition of the electronegativity is the ability to pull the electrons, the bonded electron towards itself. And then they actually found out that you can actually give number, okay? You can read more, okay? They actually have what we call as Pauling scale. According to Pauling scale, okay, this is not in your syllabus. According to Pauling scale, they have number 0 until 4. Okay, 0 until 4. 0 is the least electronegative. 4 is the most electronegative. So they found out the number that actually goes to carbon and the number that goes for hydrogen, the number is almost the same. So when you compare, like imagine I just come with a random number, if it is 1 and 1, so they are almost the same. So maybe it's 1.01, something like that. So they still stay in the middle. But chlorine, it's closer to 3. So they will pull towards, it's more electronegative. Okay, so if you want, okay, that is actually the best explanation that I can give. Okay, but if you want easier way, please remember carbon and hydrogen at all times, they are always going to be almost the same. So electronegativity, there is no much difference. They are not going to go left or right. Okay, that means your alkane, okay, hydrocarbon, all of your alkanes, they are considered to be non-polar. Okay, later we will discuss about that. Okay, now let's say since you actually learn about this molecule BF3, okay, I'll give you this example, BF3 and ammonia. Ammonia will have this molecule. BF3 is group 13, okay, 3 valence electrons. So you have F, F, F. Now, if I actually look at my periodic table, okay, boron is group 3, F is over here. Of course, I told you the one that is towards your right hand side, they will have, okay, a greater electronegativity, okay, because I want you to remember this one, the one that towards the right, they will become smaller and smaller. It means fluorine have a greater electronegativity compared to boron. So what happens, the electron pair, they will be pulled towards fluorine. The electron pair will be pulled towards fluorine. They will be pulled towards fluorine. Now, for this one, okay, but I'll come back to that later. Now, for this one, the hydrogen and nitrogen, okay, if you look at the periodic table also again, nitrogen comes somewhere in the group 15. Okay, hydrogen, just take it, hydrogen being the least electronegative. Okay, it means they are the weakest. Okay, just imagine that they are the weakest. So what happens, the electron will go towards nitrogen. Okay, and there is electron, the lone pair of electron over there. Now if I put it as an overall molecule, what happens is towards the top, okay, it means towards the top of the nitrogen, you have a lot of electron. Therefore, this side is delta negative. This side is going to be delta positive. So this molecule is polar. But this one is going to be different. Why? Okay, I'm very sure you have learned about in physics, it's called equilibrium. Just imagine at 120 degrees, okay, when people are pulling with the equal force over here, what happens? Everything stays in the middle, right? So it means that, okay, even though, okay, there is a polarity, okay, even though there is a polarity, those polarity is being cancelled out. Okay, we call it the dipoles. Okay, dipole means positive and negative. The dipoles are being cancelled out. Now, this one, the cancelling of dipoles can only happen if the molecule is symmetrical and having the same elements. It means must be all F. Cannot have lone pair. Okay, cannot have lone pair. So this one, when the dipoles are being cancelled out, we call BF3 to be non-polar. Even though the bond itself is polar, but they will be cancelled out. Now, another example that I can give about being cancelled out is like this. If you have Cl, 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 and Cl like this, we know chlorine is more electronegative, okay? They will be pulled towards chlorine. But do remember, okay, this is tetrahedral, it is symmetrical, and at all directions, the electrons are being pulled. So what happens, these dipoles, again, they will get cancelled out. Okay, when they get cancelled out, automatically, okay, automatically this is going to become non-polar. But if I change this into H, everything will change. Okay, it means there is more electron towards here. Okay, so it will become polar. Okay, so please take note of this. I will actually discuss this in detail, okay, soon. Okay, first of all, I just want you to actually understand about the term polarity. Okay, it means two things here. I want you to understand about the term electronegativity and polarity. Okay, and this polarity, okay, we call it dipole. Okay, dipole means positive and negative. It's called dipole. Okay, polar means, yeah, if you have dipole, that molecule is known as polar. Okay, so sometimes the bond can be polar, but the entire molecule will not be polar. Why? Because we follow the principle of cancellation. So if you can cancel each other, like another example I can give you is BeCl2. Okay, we know that this one they will pull here, this one they will pull here. There is no lone pair of electrons. Of course, this one is going to be non-polar. Okay, will be cancelled out. But another example is going to be water. Okay, now water is going to be different. So here, even though they are going to be coming over here and then it looks some sort of symmetrical, but take note, this molecule is not symmetrical. It's going to be like this. Okay, just imagine there's more electrons over here compared to here. Delta negative, delta positive. Water is non-polar. Water is polar. Okay, water is polar. Okay, I hope you understand this. Okay, but I will repeat again. Okay, don't worry. Okay, please read on that.